Hello and welcome to this class. Today we have further mathematics and we are going to discuss polynomial. A polynomial in mathematics means an expression that contains many terms. An expression that contains many terms. A term is either a variable or a constant. And I believe you know what a variable is and what a constant is. A variable means something that can change or something that can be replaced with another thing in mathematics. For instance, if you have A, we can replace A with B, we can replace it with C, we can replace it with D, with anything we like. You can even replace it with a shape. So these are variables because they can change. If you have 2x, we can write it as 2a, we can write it as 2c, we can write it as 2d. Anything we like, you can use it to replace these alphabets. So the alphabets here are variables. Now we have a constant. A constant is the part of a term that cannot change, or a term that cannot change. Something like a number. If you have 5, it is a constant. Anywhere you have 5 in an expression and you change it to another thing, maybe from 5 to 2, you have changed the whole expression. It will not give the same meaning again. So numbers are always a constant in expression, while alphabets are always variables. Now when we combine these things, we come up with what we call a polynomial. Every polynomial has 3 components. Every polynomial has 3 components. The first component is what we call the variable. Now the second component is constant, and the third variable is what we call exponents, components. We have variables, we have constants, and we have exponents. A variable, like I've defined, is something that can change in mathematics, or something we can replace with another thing without losing the meaning of the expression. Now, a constant is the one that cannot change, while exponent means the power of either the constant or the variable. If you have x squared, the power here, which is 2, is called the exponent. If you have b raised to power 3, this 3 here is an exponent, that is the power. So the power in an expression or in a term is called the exponents. So these are the components of a polynomial. Every polynomial contains a variable, a constant, and an exponent. In polynomial, we have 3 types of it. We have the one we call monomial, we have the one we call binomial, and we have the one we call trinomial. So we have 3 types of polynomial. The types: 1, monomial, 2, let me write it well, monomial, 2, binomial, and 3, trinomial. Now, a monomial is a polynomial with one term. A monomial is a polynomial with one term. Binomial is a polynomial with two terms, while trinomial is a polynomial with three terms. In binomial, the two terms must not be the same. That is to say, the power or the exponents of the terms must not be the same if their variables are the same. For instance, if you have 2x raised to power 3 plus 2x or plus 3x, now this is a binomial because this has a power of 3, this is a different term, and this is a different term. This has a power of 1 and this has a power of 3. But if we have 2x raised to power 3 plus 3x raised to power 3, this is not a binomial. This term is the same as this term because the variables are the same and the powers are the same. If the variables and the powers are the same, then we can add them up to become one term, and one term is a monomial. Example of monomial is if you have 2x raised to power 2, 5x or 5b, just one term is called a monomial. Now two terms like this one is a binomial. Then when we have three terms, like if you have three terms like this one, if you have three terms like 5x raised to power 2 plus 3x plus 1, this has three terms. This is the first term, this is different from this, and this is different from this. 5x raised to power 2. Now this has the same variable with this, but this has an exponent of 2, while this has an exponent of 1, and this is a constant. So we have three different terms here. So this is a trinomial. So these are the types of polynomial that we have. The monomial, which has one term, like 2x raised to power 2, 3x raised to power 4, just one term in monomial. In binomial, we have binomial which has two terms, two different terms. The terms must not be the same, like 2x raised to power 2 plus 1. This is one term which is different from this term. So this is a binomial, and we have a trinomial which has three different terms like this one. Now we have what we call degrees of polynomial. The degree of a polynomial is the highest power in the polynomial. The highest power in the polynomial. For instance, degree of a polynomial, the highest power. Now, for instance, if you have this expression 5x raised to power 3 plus 2x raised to power 2 plus 2x raised to power 2, here the power of x here is 3 and the power of x here is 2. Now the highest power is 3, which means that the degree of this polynomial is 3. Another example, If we have 2x raised to power 6 plus 4x raised to power 3, the power of x here is 6, while the power of x here is 3. Now the highest one is 6. Therefore, the degree of this polynomial is 6. If you have another example like 4x or 4b raised to power 2 plus 3 plus 3b raised to power 4. Now here, the highest power is 4. Here is 4, the power is 4, and here the power is 2. Therefore, the degree of this expression is 4. Remember that the variables can be the same or they can be different. We can have 2x raised to power 3 plus 5b raised to power 2. Now here we have different variables in the same expression. This is still a polynomial. Now the power here is 3, while the power here is 2. This is the highest power in this expression. The highest power is 3. Therefore, the degree of this polynomial is 3. Now, we have rules that guide the identification of a polynomial. It is not just every combination of variables or variables and constants that is a polynomial. If we have a polynomial rules for identification of polynomials. In polynomial 1, exponents of polynomial cannot be negative. The exponents cannot be negative. Cannot be negative. That means that we cannot have something like 2x raised to power minus 2. Because the power here is minus 2, this is not a polynomial. If the power or the exponent is negative, it is not a polynomial. 5b raised to power minus 3. This is not a polynomial because this power here is negative 3. It has negative, so it's not a polynomial. That is rule number 1. Now, rule number 2 in identifying a polynomial is that the division by variable is not permissible. Division by variable is not permissible or is not allowed. You cannot divide a value with a variable in polynomial. For instance, we cannot have 1 over x plus 2. X here is a variable, and because it is a variable and it is under this value 1, this is not a polynomial. You cannot divide a value with a variable in polynomial. If you have 2 over a plus 5, this is a variable. This a here is a variable. Therefore, this expression is not allowed as a polynomial. That is rule number 2. Now, rule number 3, fractional exponents is not allowed. fractional exponents. Fractional exponents is not allowed or is not permissible. Now, a fractional exponent is something like if you have x raised to power 1 over 2, this power here, 1 over 2, is a fraction, and fraction is not allowed as a power of a polynomial term. So this is not a polynomial. If you have 6x raised to power 3 over 2, this power here is a fraction. Therefore, it is not allowed as a polynomial. But you should know that if we have something like x, if you have x raised to power 4 over 2, 2 can divide 4 to get a whole number. So this is actually x raised to power 2. So this is not actually a normal fraction. So this is allowed. This is not a normal fraction. It's not a proper fraction. So this is allowed. But when we have something like improper fraction or mixed fraction, it is not allowed as a power in a polynomial. So when you are given a power and you are asked to identify whether it is a polynomial or not, first of all, check if the powers, if the fraction can divide to get a whole number. If it can divide to get a whole number, then that means that it is not actually a fraction. So that one is a polynomial. But if you cannot divide it to get a whole number, it is a normal fraction. Therefore, it cannot act as a polynomial. Now, the operations or arithmetic operations in polynomial. Arithmetics on polynomial. We can perform addition to subtraction 3, division, and 4, we can perform multiplication on polynomial. Now let's start with addition. Let's talk about addition and subtraction. Addition. How do we add polynomials? If you have two polynomial terms and we want to add them, we arrange the terms in a column. Put the terms that are like under the same column and then add. For instance, if you have 5x raised to power 3 plus 2x raised to power 2x, now plus 3x raised to power 2, 3x raised to power 3 plus x. If you are asked to add this, what we do is that we create a column, we create a table, we write the first term is 5x raised to power 3 plus 2x, 5x raised to power 3 plus 2x. Then the second one, the second polynomial, 3x raised to power 3 plus x. Now this one has the same power as this and the same variable. This and this, they have the same variable and the same power. If the term, they have the same variable and the same exponents, we put them together. We put the other one under it. So we are going to have here 3x raised to power 3. Now this is x and this is 2x. So the same variable and the same power, the power of 1, the power of 1. So we put two of them under the same. We have x here. So we now add. We are now going to have 5x raised to power 3 plus 3x raised to power 3 is 8x raised to power 3, and 2x plus x will give us 3x. So this is the answer when we add 5x raised to power 3 plus 2x and then 3x raised to power 3 plus x. Another example, if we have 2x raised to power 4 plus 3x raised to power 2 plus x raised to power 4 minus 2x raised to power 2. Now we arrange them again. We put the like terms together. So we are going to have, the first one is 2x raised to power 4, 2x raised to power 4. Now we look for other ones that have the same variable and the same exponents and put them under this. Now we have x raised to power 4, x raised to power 4. Now the ones we have 3x raised to power 2, this is plus 3x raised to power 2. Now we look for other ones that have the same variable and the same exponents and put them under this. So we have 2x raised to power 2, that is minus 2x raised to power 2. Now having arranged them like this, we now add 2x raised to power 4 plus x raised to power 4. This will give us 3x raised to power 4. Now this is 3x raised to power 2 minus plus minus. This is 3 plus minus something. That is 3 minus 2. 3 minus 2 is 1. So we are going to have plus 1 plus 1x raised to power 2 plus 1x raised to power 2, and 1x raised to power 2 is the same thing as x raised to power 2. So the answer is 3x raised to power 4 plus x raised to power 2. Another example, we can have even up to 5 different expressions, polynomial expressions, and then add them. We can have x minus x raised to power 3 minus 2a raised to power 2 plus 3a raised to power 2 minus 5. We can be asked to add this. Now, how do we do it? Put the same terms on the same column and add. We start with x raised to power 3. X raised to power 3. Is there any other one that has the same variable and the same exponent? None. So we leave it. Minus. Now come to 2a raised to power 2. Now, is there any other one that has the same variable and the same power? Yes, we have 3, that is plus 3a raised to power 2. Now we have 5. This is minus 5. There is no other constant. So we draw our line. This is x raised to power 3. We just bring it down since there's nothing we are adding to it. Now this is minus 2 plus 3, which is 1. Minus 2 plus 3 is 1. So we have, this is a raised to power 2 and then this is minus 5. So this is the answer. X raised to power 3 plus a raised to power 2 minus 5. If you have 2a raised to power 3 plus 3ab plus 3a raised to power 3 minus 4 plus 5ab plus 2, and we are asked to add this. Now what we do is still the same. We start with the first term, 2a raised to power 3, 2a raised to power 3. Is there any other one that has the same variable a and the same power 3? Now we have 3a raised to power 3. So we put it under it, 3a raised to power 3. No other one. Now we go to the second term in this expression, plus 3ab. Now we look for another one that has the same variables, ab. They are different variables in the same term here. So which other one has ab? We have 5ab, and they have the same power. So we put them under it 5ab is actually a plus there, so we have plus 5ab. Then we go back, go to the third one. Which other one we have? We have constants. Minus, the first constant is minus 4. We have minus 4 minus 4. Remember, everything has to be on a separate side. Minus 4. So any other constants, we have plus 2 plus 2. This takes a column, this takes a column, and this takes a column. Each term takes a column. Now, after everything, we draw our line and add from each column. 2a plus 2a raised to power 3 plus 3a raised to power 3 is 5a raised to power 3. Now 3ab plus 5ab, this is plus 8ab minus 4 plus 2 is minus 4 plus 2, which is minus 2. So minus 2. So this is the answer. 5a raised to power 3 plus 8ab minus 2. Now we go to subtraction in polynomial. Subtraction is done the same way we do subtraction, the same way we do addition. We put them under the same column and subtract. For instance, if we have 2x raised to power 4 plus 3x raised to power 2 minus 3x raised to power 4 plus x. Now we put the like terms under the same column and arrange them, then we subtract. So what we are going to have is the first column, we have 2x raised to power 4. Any other one with the same variable and the same power, yes, 3x raised to power 4. So we put it under it, 3x raised to power 4. This is the first column. Second column, 3x raised to power 2, 3x raised to power 2. Any other one with the same variable and the same exponents? No. So we leave this. The third one is x. So we have x in the third column. And now we add this plus this is 5x raised to power 4. We bring this down. This okay, so this plus becomes this plus 3x raised to power 2 plus x. So this is the answer. Example 2, we can have 4x raised to power 2 minus ab minus bracket 2x raised to power 2 plus 1. Now how do we do this? The first column, 5x raised to power 2. Any other term with the same variable and the same exponents. We have 2x raised to power 2. That is under the same column. Then we have minus ab. Any other term with the same variable and the same exponents? None. So we leave the column. We come to another one. We have constant 1. So we have 1, which is plus. We must always put the signs. It is important. Now we add 5 plus 2 is 7. So we have 7x raised to power 2. We bring this one down, minus ab plus 1. So even in this place, we have to always put the sign. This is plus, and the x here is plus. Plus. Okay. So you must always put the term with its sign. So this is the answer, 7x raised to power 2 minus ab plus 1. So this is how to do addition and subtraction in polynomial.